This is the setup of the cloud thermometer sketch, and what you'll want to do before you get to this point is go through the calibration and get the 3 coefficient values. You're going to need that here. You'll also want to have the DynamoDB table set up and get the credentials for a user that has read-only access to that table. And you'll also need the credentials for your AWS account. What you'll want to do first is load the cloud thermometer sketch in Arduino. I've already done that here. And you'll also want to make sure that you have a few dependencies installed. Make sure you have the CC3000 library and the RTClib library. Both of these are the dependencies of the sketch. And if you don't have those installed, make sure to follow the links here and install them, and then restart Arduino and load the sketch again. And what you'll want to do first is go through and change some of the configuration. So the CC3000 configuration is at the top here, and these are just which pins are hooked up to which parts of the CC3000. This is all standard CC3000 configuration that all of the example sketches use, so nothing deviates here from what you might have used in examples before. For the wireless network configuration, you'll want to change this to your wireless network SSID, password, and security type. And then finally, the rest of the configuration is for the actual cloud thermometer. So the thermistor configuration, this just lets you choose which hardware pin you're going to read input data from the thermistor probe on. In my case, my hardware, I'm using analog input 3. The series resistor, this is the resistance of the resistor that's in series with the thermistor in ohms. And if you've built the hardware in this guide, then you should be using 10,000 ohms. And the ADC samples, this is just the number of samples that are taken and averaged for an ADC reading. Stick with the value 5 here. It's just a good default. Now the next values, these are the A, B, and C coefficients for the Steinhart-Hart equation. And you'll want to get these from the calibration that you've done earlier. And I'll grab these values that I've saved and copy them in. So those values are in. The next thing is the DynamoDB table configuration. So the table name, this is just which table to write data to. And if you followed the guide so far, then you've created a temperatures table. The ID value, so this is the value of the primary key that data is stored in the table. So every time you start a new temperature measurement, for example, if you're starting something new in the oven, like you're starting maybe a chicken or a pork roast or something like that, you'll want to assign a new string value to this set of temperatures. And what that will do is that will just make all of those temperatures a part of one ID value. It'll be a lot more clear once you load the web page. You can actually see a list of all the different unique ID values, and you'll choose which one inside of there. So in this case, we'll just say test ID value. Now the next configuration, this is your AWS access key and your secret access key. These are the credentials for your personal AWS account, and you'll want to copy these in. This can't be that read-only user. If you try to use the read-only user, it's going to fail because this is the credential that's used to write data to the database. It might be best practice to actually go and create a user that has write access so that you don't have to use your own credentials inside of here. But if you know you're not going to lose your hardware or you have access to it, then it's probably safe to put your Amazon credentials inside of here. And I'll copy those in later so that I don't show them here. Now the AWS region and host, this depends on where your DynamoDB table lives, and I'll show you how to figure that out. So if you go back to aws.amazon.com and you log in with your AWS account to the management console, this will take you to a view that lets you see all the Amazon services. And right now it's in a global view here, so it's not showing me anything specific to a region. If I click on DynamoDB, this is going to show me which tables I have, and here's the temperatures table that we created earlier. And up in the upper right, this is actually showing me which region this table lives inside of. So if I switch to another region, like let's say Europe, you'll see I don't have any tables inside of here. So you need to make sure that you have the right region selected. In this case, this one's created in Oregon. And this is the actual region value that we'll use to look up the URL and the region inside of the sketch. So remember this, and then inside of the comment, it points you to this table here. And this is a table that tells you, based on that region name, like the US West region that I'm in, what the actual region value is and what the endpoint to use. So I'll need to copy in this exact region value and put it here. And then I'll also need to copy in the host value here. So I want to pick the same host value for my region. And we'll copy in the exact value there. And that's important because if you get this wrong, you'll fail to find the database. Your sketch won't write any data to the database, and things just won't work at all. The other configuration here, you probably don't need to change any of this. This is just the delay in minutes between writing new samples to the database. So stick with 1 minute. Maybe you could increase this. You could even decrease this. But again, be careful going too much quicker than once per minute, because the throughput limit on your table is once a second, and so you don't want to go above that. Otherwise, you might start incurring some costs. And the timeout in milliseconds, this is just how long to wait when requests are made to different services. The sketch actually has to query an NTP time server to figure out what the current time is, and then it also has to query Amazon's web services internally. And then the target and service and signature start, these values you shouldn't change at all. It's just good for reference, and if you want to extend this sketch and call other Amazon web services, there's this very complex signature process that this sketch implements. You have to do about 5 or 6 different SHA-256 hashes. And so all of that you can actually use with other Amazon web services. But in this case, I'm only calling this DynamoDB put item API call. And so you shouldn't change that if you're using this sketch. So with all of that done, you should be ready to go. I'm going to copy in my access keys and then come back in just a moment, and we'll compile this and load this on the hardware. And we're back. So I've copied in my access keys, and let's compile, and then let's load it on my hardware. And you might notice that the sketch takes up quite a bit of data, so there's only about 300 or so bytes available. And unfortunately, that's just a side effect of all the signatures and different things you have to do to call the Amazon Web Service API. On an Arduino Uno, you have a little bit more free space. There's about 2 kilobytes free, but just something to be aware of, that when you call these different APIs, it takes up quite a bit of space, and so there's not much available. So that's loaded. So let's open up the serial monitor. And we should see it'll connect to my Wi-Fi network. It usually takes about 30 seconds or so. Okay, now it's running. Okay, so now you can see there's a little bit of text that's displayed here, and basically every minute when it takes a new sample and it writes it to the database, it's just going to write out the raw request data or response data from the Amazon Web Service API. So you can see this is connecting to that Amazon Web Service host URL. It's sending some data, which you don't see here, and then it's just echoing out the response that it gets back. And you want to make sure that you see this HTTP 1.1 200 OK response. If you don't see that response, then it's not working and data is not being saved in the database. You might see something like maybe a 400 bad request, or maybe a 403 forbidden response. If you see anything like that, go back, double check, and make sure that you've got your access keys set correctly, you've got the region set correctly, you have the endpoint URL set correctly. Those are things that could cause this to fail. And so you can see every minute it's just grabbing a new sample and sending it out to the database. And so now we'll see how we can actually visualize this data. So let's move over, and you'll actually want to go and edit some of the data from the sketch. So let's open up the actual sketch folder. And so let's go into the Cloud Thermometer, go into the web page directory, and edit index.html. So open that in a text editor. And let's just make a little more room here so this is visible. Okay, there we go. So you'll want to scroll down and you'll want to change one thing inside of here. So find the line that says put your read-only user access keys below. So we need to edit this web page and insert our access keys so that when someone views the web page, it'll use those keys to query DynamoDB. These are the keys that you generated in the previous step where we created the table and created the read-only access user. So I'll grab those keys right here, and I'm okay showing you these because I can just delete this user later, and even if these keys got out, they only have read access to my database, so I'm not really super concerned about them. So I'll copy both these keys in. And then one more thing you need to change. The region again has to be set here, and so I'm in US West -2. So save that file, and if you're unsure, here's the link that takes that table that lets you see where the region values are set. So we'll save that index.html, and now we'll actually need to load this on a web server and serve this as a web page that I can access. And there are a lot of different ways you could do this. You could actually take this web page and put it in Amazon's S3 simple blob storage service. That's really good if you want public access to this, if you want to view from a cell phone. It's a little more complicated, and it's maybe not something that you have to do. If you're just going to view on your own network, maybe from like another computer or a tablet or something like that, you can actually just use Python. It has a really simple web server built into it. And so what you'll want to do is just open a command window and make sure that you have Python installed. You just need either Python 2 or 3. The version really doesn't matter. Navigate to the sketch directory, and you'll see inside of there's a web page directory. So navigate inside of that web page directory and then run the command python -m simple HTTP server, and that's just going to run a very simple web server, and you can see that it's running on port 8000 of this machine. So let's go to a browser and let's actually access localhost port 8000. And so you can see it's loaded up the initial cloud thermometer visualization. Now the measurement, this is actually going to list out all of the different ID values, the unique values that are inside the database. And so remember, that's what you set inside of the Arduino sketch with the ID value. So every time you start a new measurement, like if you're starting a new piece of food in the oven, or measuring some kind of new unique temperature measurement, set a new value inside of your sketch. Save it, load the sketch on your hardware, and then when you view the web page, you'll be able to see a list of all those unique values. So if I load this up, by default, it's going to show a bunch of fancy things here. I'm going to turn off the trend line, and we'll keep this refresh turned on. And so you can see these are the measurements that it's taken so far. And so every minute it's been taking a measurement. You can see kind of behind here with the serial monitor that it's outputting data to. And you can do a few things inside of this view. So you can see, you can change the units between Celsius and Fahrenheit. You can change the target. So if I want to go higher or lower, it just defaults to 160. You can draw the trend line. And unfortunately, the trend line really isn't interesting right now because my temperature probe is just sitting on the table. And so it's only measuring 68, 69 degrees or so for the ambient temperature. You can also export the data as a CSV file. This just gives you one column with the date and with the temperature in Kelvin. And that's basically everything that you need to view the temperature data here. So if this was really something you had in the oven, you would see over time the temperature increase, and you could actually draw up the trend line and see what the estimated finish time would be. So that's the Cloud Thermometer project. Just at a high level, it's an example of logging data to a cloud web service. In this case, it's Amazon's DynamoDB service. And we're just using an Arduino and the CC3000 Wi-Fi chip to log that sensor data, which is just a thermistor probe, directly into a database, and then view that inside of a web page. And you can do a lot of things to extend this. You could add other types of sensors. You could have multiple temperature probes. You can call other Amazon Web Services to do more things. There's lots of different ways that you can take this project from here. But for now, it's just a great example of a useful gadget that you can use to monitor what you're cooking.